All right, our theme to, let me turn that on. Our theme today is going to be ensuring that you have accurate data. Let me give a for instance. For instance, in the pizza example that we have, there were only two possibilities for crust, thin and thick, if I remember right. Now, that was a string, however. Now, a string, you can put anything you want to in it. And obviously, if you put in something that wasn't thick or thin, it wouldn't necessarily work. Likewise, the sizes, small, medium, and large, S, M, and L. You put in XL, or you put in P for personal, or something like that, it wouldn't work, and it wouldn't do the calculations correctly. So far in this course, we've said, we know that's a problem, and we'll deal with it later. So we wrote our set methods, and we didn't do any validation in them, didn't do any validation in the constructor, and so on. Well, later is now. All right, so now's the time we're going to look at how we make sure that we have valid data in that. Another example, which is specific to your assignment, that a residency code for a student has to be either in county, out of county, or out of state. If you gave something that wasn't one of those three values, the calculation wouldn't work. It probably shows zero tuition. Likewise, credit hours need to be a positive number. If you had a negative number, that would actually reduce the student's tuition if you calculated tuition with it. So therefore, we have to do something to make sure that those errors don't occur. So I'm going to show you a couple ways to do that. And one of them is called exceptions, and one of them is called enumerations. I'm going to switch things up a little bit from the way I normally do it. And we're going to do enumerations first, because I think we can do this fairly quickly and get it out of the way. All right. So let's go in. And get into the appropriate directory. We're going to run it, and we're going to see what the results are. And then we're going to show you how this is different than what we did before. So we have the same classes that we have had before in our pizza world. You notice, though, there's something else. There's a pizza $ pizza size class. That is where the enumeration is, and we'll see how that works in a second. Let's run it and make sure that it compiles and runs. All right, large has pepperoni false, cost us $10. Crust is thin, crust is thick, bake time is 16 minutes. Medium with pepperoni is $10. So the order cost is $20. All right, pretty much the same as we've always had. And I trust that those numbers are correct. but let's look specifically at the pizza class. In the pizza class, right off the bat, you see what we have is an enumerator, enumeration. This is specifying the legal values for our enumeration called pizza size. All right. We can then use that enumeration like a data type. If you remember before in previous examples, we did with size what we did with crust, is we just had a string, private string crust. Here we've said that a size has to be one of the values in pizza size, that is small, medium, or large. We then change the calculations a little bit to say, instead of if size is equal to small or medium or large, we say if size is equal to the enumeration name and the specific value. So if the pizza is small, then it's going to set the cost at $6. If it's medium, cost at $8, large, cost at $10. And if it has pepperoni, it will set the cost at $2. Now we've changed all the functions that access that. We've changed the constructors. No longer accepts a string for this. It accepts a pizza size enumeration, both in the constructors, on the set method, and on the get method. So that's how we change this object. How we change the test object is to create our objects using those enumerations instead of the string values. So instead of saying set size of large, I say that the size of the pizza is pizza.pizzasize.large. That means in the pizza class, there's an enumeration called pizza size right here. And we want this particular pizza to have a size of large. Likewise, this one, when we create it, then when we output it out, we'll get the name of that, the value of that enumeration, and say the size is either medium, large, or small, depending on what the value is. Medium, large, these two cases. So by doing that, you ensure that someone can't go and put some other value in. Because if I go and say in here, if I try to make it something that's not in the enumeration, like a string of XL, I'm going to get a compile error because XL is not in the enumeration. Likewise, if I did something like this, I'm going to get a compile error for the same reason. That's not in the enumeration. It has to be one of those values that's defined in the pizza size enumeration. It has to be either small, medium, or large. Now let's do this for the crust, because we've done this for pizza size already. Well, let's take this from the ground up and let's convert crust the same way. So this relates to a field in the pizza class. So we're going to create our enumeration in the pizza class. So I'm going to define the enumeration as pizza crust and give the values of thick and thin. All right, I'm going to have to change that wherever I am using wherever I'm using the crust. So I'll change it in the constructor, change it in the other constructor. I'll change it in the set crust. I'll change it in the get crust. And where we use the crust here, instead of saying if crust equals thin, I will say if crust equals, two equal signs, pizza crust dot thin. And if I'm not mistaken, that took care of everything. I'm going to have, so I can save that. I'm going to have to change the constructors here in the unit test class to say pizza crust thin. And here, when I use it, I have to say pizza crust thick. Save that.
You spelled the pizza, I think.
Which line? Over here.
Yeah.
Thank you. So save that. Pilot. Oh. Got to do a few things. This shouldn't be in quotes, first of all. Secondly, I forgot to say that crust is now a pizza crust type variable. Think that might be all my errors? We'll find out. Okay, one more. These are both in unit test, or a few more. One I think should be capitalized. Because that's what I called it in the enumerator. Enumeration. Okay, compiles cleanly. That's one nice thing about Java is like you might have a bunch of errors, but you do one thing and that might clear up a bunch of them. So we can run Java unit test and we should still get the same results that we got initially, which we do. The bake time for the first one is 10 minutes. The bake time for the second one is 16 minutes because its crust is thick. The first one is large with no pepperoni, so the amount is $10. The second one is medium with pepperoni. That's also $10, and the order cost is $20. So we've made this class way better because you can't trick it and give it an invalid value. All right. We've built those changes right in the class itself. There's a notion in object-oriented programming called encapsulation. And that means everything about a particular entity lives in its class. So I didn't write validation in my unit tests to make sure that there's a valid value for crust and a valid value for size. I created an enumeration and put that in my pizza class so that it doesn't matter where a pizza is created, whether it be created by the unit test code or whether it's created by a GUI. It doesn't matter. You need to give it something that matches the enumeration. So you need to use the enumeration when you're setting the variables, when you're creating a pizza or setting the value of a pizza's crust or size. So this goes a long way in making sure that there are not errors or problems. Unfortunately, we can't use this to solve every problem. This is useful when there's a finite list of values that something can have. So I was going to say that the question with credit hours in your example, we've defined credit hours as an integer, and credit hours are going to have to be greater than 0. I guess we could make an enumeration with the values 1, 2, 3, and 4 in there so that you could only enter that in. But you could also do the validation where credit hours is greater than 0. All right, let's look at exceptions, the other way that you can do this. Look at the very first example, and this is simply a class called test exceptions. I'm going to comment out these lines of code. In fact, let me just delete them so you can't see them at all. What I've done here is I've made an array list that contains strings. I've created the first element that says hello. I've created the second element that says goodbye. I'm going to then loop through for I equals 0, I less than 2. And I'm going to print out the length of each of these strings. So it will print out 5 for hello, and it will print 7 for goodbye. For now, just ignore the try and the exceptions. We'll come to those in a minute here. We compile it, and we can run it. And right now, there's no problems. And it displays 5 and 7, just like predicted. It displays the size of the first one and the size of the second one. Now, let's start breaking things. All right. And I am actually going to create a backup of this. Then I'm going to go in and edit the original and show you what happens if we do not have exception processing. So I'm going to eliminate the try catch. And this is just going to loop through for each thing and display the length of the string. So I want to back up. Okay, I'm just going to compile the one. And if I run it, it's going to give me the correct results. Now let's try messing with this a little bit. Like, what if I mistakenly say for I less than 200? That's going to go through the loop and it's going to try to pull up element 0 from the array list, element 1 from the array list, element 2 from the array list, element 3, and so on. It's going to pull those all from the array list. Well, there's only two elements, element 0 and element 1. So when it tries to pull element 2 from the array list, it's going to get an error. So what's it going to do? Well, it's going to give us an exception, right? Now, blowing up like that is not good for programs. When you have a program that terminates like this is called, sometimes in the old days, they called it an ab end, an abnormal ending, an abnormal termination to the program. Because if there's an error, we might want to do something with it. We might want to print out a user-friendly error message on a screen. We might want to put the results to a file. We might want to control what we do with that error instead of having the program simply skid to a halt. All right. And that's where exceptions come in. Another problem that we could have is what if I go in and set one of the classes to null? So I'm going to set the element 1 in this array list to null. Well, what's the length of a string that doesn't exist? It sounds like a topic for a philosophy class or something more than a computer programming class. Point is there is none. There is no length to a string that doesn't exist. And that's what we're asking for. And boom, we throw another exception. And this is a very popular exception. If you're not careful, you'll get one of these, null pointer exception. What that means is you're trying to access an object that doesn't exist. In other words, that variable points to no object. It's a null pointer. It points to nothing, null. All right, which is what we engineered here by simply saying, okay, we're going to force it to be null by doing this. Okay, so these are two problems that this could potentially have. Is if we went off the end, or if we have a null object in there. These don't show up as compiler errors. You might think that the compiler would be smart enough to do that, but it doesn't execute the program when you compile it. It just looks to see if syntactically the program is correct. It doesn't look for logic errors when you compile it. So what I'm going to do is I'm going to restore our original back. And now I have error catching in here. Let me save it back under its original name. Now let's look what we're doing. We have this statement in a try statement. What does that mean? It means let's go and execute that statement, or rather let's try to execute it. But associated with a try is at least one and possibly more than one catches. And what that catch is it allows us to put code in there that will execute based on the error that's received. So for example, in this case, if we get a null pointer exception, we're going to output a nice, neat error instead of that ugly exception that we got. And we're going to say there's a null string at position number, whatever. If we have an index out of bounds exception, in other words, if we have an invalid subscript, we're going to display this error message. So that's the way a try catch works. We're going to try these statements. If one of these two exceptions is encountered, then this executes, or this executes. And it runs and it gives an exception for all of the indexes that didn't exist. In other words, from 2 through 200. And the first one, there's a null string. So we get displayed a nice, neat error message. So notice a big advantage to this. The first time when we ran it, when there were no exceptions and no try-catch blocks, the first time there was a problem, the program stopped executing. And it displayed a Java virtual machine message that may or may not have been meaningful in helping someone to debug what was going on. This, however, we're able to go and continue and display a specific error about exactly what happened, and we can continue and still finish the job. And the program ends normally. It doesn't end abnormally. So by putting these try-catch blocks, we can keep the program from crashing, and we can display an error message that we want to display to the user if there is certain exceptions that that occur. So this is just one example of how we can use exceptions. Now again, this is kind of contrived, right? no one would put this code in their loop because it gets rid of an object. Likewise, you wouldn't use 200, you'd say the length of the array list. Okay, but still, this was just meant to demonstrate how through using exceptions, we can get the program to continue, display an error message and continue instead of completely crashing. All right, let's look at our second exceptions example. I keep closing out of command line. In this case, I have a triangle object. Let's take a look at these objects. Those errors that we got were system errors, all right, generated by the system. Here's a case of an exception that I'm going to try and catch, and it's an exception that I defined. All right. I have a triangle. Triangle has one argument. It accepts 3 sides. Okay. Now, what can we say about those 3 sides? Well, we know they have to be positive numbers. The other thing we have to say is that no side can be less than, let me rephrase that. The no side can be greater than the sum of the other 2 sides. So let me show you what I mean by that. Shortest distance between 2 points is a line, right? So if we have a triangle, it's 3, 4, 5. That's a valid triangle. How do I know that? Because 5 is less than 3 plus 4. 3 is less than 5 plus 4. And 4 is less than 5 plus 3. What do I mean by that? Let's say 5, let's say this value was 1. If this value is 1, then 3 plus 1 is 4, and 5 is not less than 4. That's a problem, right? Because we shouldn't be able to go from this point to this point to this point shorter than from this point directly to that point. So really, if we had this, then our triangle would look something like this. It wouldn't be a valid triangle, all right? If you're telling me that this is a valid triangle and these are the dimensions of it, then that's not a valid triangle. Because to go from here to here, this way only takes 4. To go from here to here with a straight line should be the least way of all, but it takes 5. So that's why I have this validation in here. I'm going to throw an exception of my own if the sides are negative, or if the sum of the sides, or any of them, the one side is greater than the sum of the other 2 sides. And I'm creating an exception. This is just a plain old generic exception. And I can, in the argument, or when I construct it, I can pass in the argument a description of the exception. So let's see how this works. I have a number of exceptions. here in the unit test. I'm first of all going to try to create an integer from the word hello. Well, that's not going to work, obviously. So I'm going to get some kind of exception for that. I'm going to get a number format exception. So I could write something like not a valid value or so if we go and run this, we're already in this time. CD. I am missing a semicolon somewhere here. Triangle line 15. I think I skipped ahead from number 2. That's the problem. I was in number 3, not number 2. All right. I go through and I get a exception for invalid format because you can't convert hello into an integer. Let's say I do this right though, and I say that the sides are 6, 1, and 8. That's not a valid triangle because 8 should be less than the sum of 1 and 6, and it isn't. And sure enough, it tells us that this is a exception. The side must be the sum of the other sides. Each side must be less than the sum of the other sides. So we're going to execute this code. If we get an exception, it's going to look at the type of exception. If it's this exception or this exception, it's going to display this code. If it's just a plain old exception, it's going to display this code. And that code is going to contain the error message that we have defined here in the class when we throw the exception. There's two parts of exception. There's code in the class to throw it, and then there's going to be code in the unit test to catch it. The code to catch the exception should be in the unit test class. Because remember, the unit test is taking place of any GUI that we would have in there. And therefore, if someone entered in on a GUI that we had a triangle that was 1, 4, and 5, all right, it should display an error. So it should be the class that throws the exception, and it's going to be the GUI that's going to take that exception and display it. In our case, for now, it's going to be the unit test class that's going to do that. Likewise, if the amount was 0 or less, or 1 or less than 1, it's going to display another kind of exception. We just have a few minutes left. I'm going to look at the third case where I did have a syntax error. I'll take a look at that. Okay, line 15 in the constructor. Oh, I should say throws, not throw. The only difference between these two is in this case, I've defined my own exception class, and I can put whatever I want to in that exception class. In the previous example, in example number 2, I just used the generic exception and threw and caught that. Here I've defined my own triangle exception. The advantage of that is I can test then in the unit test code. I can test especially for that exception. So my catcher can catch any triangle exception and keep it separate from these other exceptions that we don't know something about. We can display that this is an exception that comes from the triangle class. So do correct that throw in the third example to throws, and play with these until you get an idea of what to do. And your next assignment or an upcoming assignment will be for you to create exceptions in the student class. One exception for if student class is has a value of residency code that's not one of the valid residency codes, and the other one for the course class, if the course had a credit hour of less than 0. All right, that's all I had for today. We'll either see you in class or see you in lab.